Surjective functions. A function f of x equals y is said to be surjective if each element in the codomain y is the image of some element in the domain, i.e., that is, a function is surjective if the range is the same as the codomain. This can be stated formally as follows. The function f of x equals y is surjective if, for all y is an element of y, there exists an x is an element of x such that f of x is equal to y. On an arrow diagram, a function is surjective if every element of the codomain has an arrow going to it. The arrow diagram opposite shows a surjective function, as there is no element in y which has no arrow going to it. However, this function is not injective. Why not? Well, it's not injective because 7 has 2 arrows going to it. And the definition of an injective function is each y value can only have 1 arrow going towards it. If a function is given solely as a set of couples, we cannot tell if the function is surjective. We would also need to know the codomain to ensure that each element of the codomain occurs as the second component at least once. Investigate if the function f of r equals r of x equals 4x plus 3 is surjective. So we can write the rule of the function as f of x equals 4x plus 3, or just y equals 4x plus 3. Then we're going to let y be an element of the real number set. Then we get 4x plus 3 equals y, so we just swap the rule around. So then 4x equals y minus 3. We rearrange to get the x on its own. So what we did was we carried the plus 3 over the equal sign to become minus 3. And then to get rid of that 4 stuck onto the x, we have to divide by 4. So we get x equals y minus 3 divided by 4. So for each value of y as an element of the real number set, this expression for x is also a real number and hence an element of the domain. So no matter what number you sub in for y, you'll end up getting a real number out for x. Thus, each element in the codomain is the image of some element of the domain, and so this function is surjective. So it's surjective because for all y values, an element of the y set, there exists an x value, an element of the x set, such that f of x is equal to y.